Okay, so this week we have Ket.G. So this is Guillermo Alonso, and he's got a YouTube channel, which is basically a quantum computing YouTube channel. I guess he's gonna talk about it later in the video. I haven't really watched his the solution of the puzzle, but he basically does this in Spanish. So he's got a bunch of quite some videos here actually. About like sort of the basics, but also then going through some of the algorithms. So I think it's if you speak Spanish, like I definitely recommend the channel. Is really good, and the videos are really well prepared. If you don't speak Spanish, maybe you can learn some Spanish while learning some quantum computing as well. So it doesn't hurt, and I think it's quite a cool channel. But let's take a look at how he did. Okay, so it was a fun. I think it was a fun puzzle. It should be in the show notes in the video description below. But let's watch his solution. So let's go ahead.
Hi everyone, my name is Guillermo Alonso and I'm a maths and computer science student from Spain. So let's start. For this task, I have the blood sphere.
I like that he's using the block sphere that he's using in one of his videos. It's a really cool. It's nice because I didn't provide the block sphere in here, so he's maybe gonna use it to just kind of reason through what he's trying to do. I like it.
To help me with the get 0, get 1, positive and negative get and so on. It's very useful. So first at all, we can see that all the states are in a 50% chance of being on. So they could be in the circumference perpendicular to the z axis. So we can check it with the x gate. Okay.
You can see he's a YouTuber. He has a good setup, not like me. Yeah, he's actually I don't know. Is he doing this on a tablet or something?
Nothing changed. So there are two options. Option number one. If we turn around the x-axis, the only two states don't change and are the positive ket and the negative ket. So we can try to turn around the y-axis and nothing happened. So the only explanation about this is that all the qubits are in an entanglement state. So we can prove to do a control X to see it. Maybe any state.
So he's trying to use
Change.
a control NOT gate to disentangle.
Okay, here's interesting. The state of the 1, 2, 3, 4,
And
5
now
qubits
I like
change
I
between
like he nailed it
minus
here.
1,
Yeah,
the state 1, and the state
I like
0.
I prepared the puzzle on purpose for this to happen, where once you disentangle, there's certain other qubits that have like sort of an animated trap. So once you disentangle them, then it starts rotating. But it should be trivial actually now.
So probably the state are turned around any axis from 1 to 0. So we are trying to find the axis of this circumference. So if we turn around the x-axis, if the circumference is this, the probability have to be 100%. So if we did it,
It's an animated gate.
nothing changed. So we can do the same with the y gate. Okay. We have turned around the
Yeah.
y-axis. So if the change now is 50% is because the qubit, the state of the qubit are in this circumference. So we have to change the phase with a delay respect the x-axis.
Okay, okay, so he figured out that's nice. Okay, so that's cool.
So
So
now
instead of trial and error, that's easy to do here. He first tried to figure out in which axis we're rotating, so he could then pick the right gate. That's smart.
the first qubit maybe can be turned off now. So with x, for example. No, why?
It's the first person I see that is
Okay.
actually using that's not
Okay.
using a hardware
We
gate.
are going to continue with the same idea and right control X. Okay. Okay, let's try the same thing before with uh with this gate. Perfect. And in the second qubit,
Nice.
perfect. Continue.
I think there's no more
Right
rotating
control
traps.
X. Oh, this is easier. Okay. And now the third qubit. Nothing. Oh, okay. So the third qubit is in target too. It's, oh, okay.
Surprise!
Yeah,
No, actually, I don't remember what I how I put it
we are
in
going
there.
to continue with the next qubit. Hmm, nothing's happening. Maybe
I didn't
with a
entangle the.
trifoliate gate, it will be. Hmm, okay, I can try the one thing. No. Okay, I don't like the trifoliate gate. Other maybe there are more difficult entangling between the third and the fourth qubit. I can try with an X gate or double X. Oh, okay, very very lucky. So now we can prove if we can change the third qubit with an X gate. No, no. Okay. With this and this now, nothing happens. Or maybe with other Hadamard gate. Eh, yes,
Nice.
perfect. So now turn off the last qubit and
Cool.
only one more.
I like that. Yes, you
Okay,
got it. Okay, cool. I like how he.
perfect. So
I like how he basically instead of so I'm a lazy guy, so if I would have put like a square root of y and seen that it goes to on, I would just then apply an x gate. And instead of that, he just goes and it's like and goes and applies the minus square root of so he saves one gate, so gotta be optimal.
we have turned off all the qubits.
Cool.
Okay, I want to thank Daniel for letting me the opportunity of participate in this video series because I think he's doing a great job. I have other YouTube channel in Spanish where we are talking about the basis concept of this field, and I think you might be interested in that. So thank you and see you.
Yeah, man, it was good. It was good, really. I'm happy. I'm happy, of the way that Guillermo solved it. I kind of like the um, chill approach to it, and then the fact that he's using, oh, here you go. This is the where he's using the key when he's using the actual, yeah. Okay, that's cool. It's cool stuff. And thank you. I hope you enjoyed the video, and check out Ket.G. I'm subscribed there as well, and I mean I can speak Spanish because actually I come from Spain. Um, but if you can't, I mean it's not, it shouldn't be difficult. Uh, and it's a cool channel. Cool. So more puzzles coming soon. More, 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 more. Yeah, enjoying this. And how do I stop?